Hello everyone, welcome once again. So we'll be for the next for this video and the next, right, we'll be bringing our FastAPI application together, and we would start testing the application. And before we do that, we are going to and one decision I've made for us to test effectively is we would, before we start fully testing our external storage to bucket, we would make our URL like image URL is equal to https www.example.com, so that we would all be able to test even without us having an external account, which we would eventually see how to create and manage, right? So, and before we proceed, right, we'll be discussing about our database layer. And our database, for our database, right, like I said in our previous videos, we'll be using an SQLite database, which would have an ID, have a URL, have detections, which is going to be a detection of dicts, JSON. We are going to have confidence scores. We are going to have model version. We are going to have actual label for review. We are going to have is correct. We are going to have created art and updated art. Created art is automatic on insert, and so that we can start testing the application even without we having an external bucket. So we just SQLite your FastAPI, we can start testing and making inferences. So let's proceed, and we'll be going to our database layer here. We're going to our database layer. In infrastructure, let's ignore this. In our DB layer now, we'll be adding a base implementation, and we'll be adding a session. So let's proceed. So the reason why we'll be having base like this, or let's start. So we'll have a base .py, we'll have a session .py to manage our database sessions, and we would have our prediction, our actual prediction .py to store our predictions. So in base, right, an important reason for base is that we might want to create a set of columns that should be available on all other tables, more like just like we have an interface, but for our repository, our interface for our model runner, this is more like an interface, but instead of an interface, right, this is an actual implementation that other classes is going to inherit, which we are going to see. So import typing from typing import dicts. So we then say import UUID. We then say from SQLAlchemy. SQLAlchemy imports our column, imports our date time, imports func, which is function, not func tools, I don't want that. We then say from SQLAlchemy.orm imports as declarative and declarative attributes, declarative attributes, ITTR. We then say from SQLAlchemy .dialects .postgresql import UUID, which we are going to use on the column. So we say our class registry is date data type and is equals to an empty date. Okay. So we then say our as declarative decorates our our base implementation class registry is equal to our class registry, and let's proceed. Our base class, not base settings. We then say this is abstract is equal to true. We then have our ID. Again, every field that we define here, or column that we define here, is going to be an actual column in our database. So we call this column. We then say we want this as UUID, and actually store it as UUID, not as string. As UUID is true. We then say we want this to be our primary key. Primary key is true. We then say default, auto-generates default to UUID.UUID4. So even if we don't send the UUID into when we are storing, it would still create a new UUID for us. Index is true. We need to discuss about indexing now. Indexing is one of the important database, normalized database or SQL database implementation that makes your queries faster. Indexing makes your queries faster, and is one of those things that you really have to take in mind. Like, you apply indexes on columns that you know you are going to query on. You are going to query on mostly. Like, let's say select let's say a sample SQL query. Select star from prediction where ID is equal to blah 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 something, right? We could actually use integer, but I'm using UUID. So we then say, after that, we then say we want this to be unique. So we don't have duplicates. IDs, unique is equal to true. We then say it must not be nullable. Nullable is equal to false. So there must always be a value there. We then say we also need any table that inherits this base class to have created at. Created at is equal to column. We have date time, data type. Then we need to, now you might say you don't need time zone. An important reason when we are building your production applications is that you need to store data, because let's say you have server A deployed in a UTC+1 time zone. Let's go into our mirror. Let's say you have your server. Your server is deployed in this zone. Let's get a rectangle. Increase in size. Duplicates. Okay, let's now get a freehand sketch. Let's say you have your user. So let's say this is your server, which is in time zone UTC+1. I want this to be increased. UTC+1. And let's say your user duplicates. Your user is in UTC+2. So now what happens is, you can get your users, how would I call it? Your user's time zone from the request, from your UI. And let's say this user sent a request by, let's say, 1 p.m. their time. What happens is, when it gets to this server, it becomes 12 p.m. And if you don't keep track of time zone, you discover that when this user coming from UTC+1, UTC+2, right? When they are coming from here to make a request to actually fetch their data, if you don't save the time zone, you just return it to them that, oh, you made this request by 12 p.m. But the moment you know that this is UTC+1 and the user is trying to get the data. After you fetch the data out of the database, you can then apply this time zone on it to say, oh, even though I saw this thing by 12 p.m., your request will actually happened by 1 p.m. So let's proceed. Time zone, use our server default. Our database server default is equal to func.now, then null label is false. We must always have created that. Index, we need to also index on created that, so that when we want to fetch data of, let's say, data from the 1st of December, 1st of January, we then need updated that. Let's make this multi-line, make it easier to read. Okay, we need to have updated that. Updated hat is equal to same thing, so which is date time zone true, server default yes. We instead of just having null label now, this needs to be we don't need to index on updated that. We can just now say, okay, I want you to have this on every update. On update is what? Func.now. We then need to have deleted ads. Deleted ads is equal to what? Our column, date time zone. Time zone true. Default should be null label, right? Since we should not be indexable, it should just have default as none instead. Default is none. Now, the reason for this deleted that is when you have a soft delete policy in your API or in your database, that even though user A says delete my database, you want to return, you want to do a data retention of their data for like the next 30 days. So you just set this flag that, okay, this thing is deleted. So any new request that is coming in, ensure you're not fetching a deleted record for me. We then need to add at declared attribute. Declared attribute. Def, we can automatically generate table name. Table name. Then it takes in the CLS, returns a string. It returns the class name, CLS dot name dot lower. So we can automatically generate table name. So we then have to create our database session. So from context lib, import async context manager. We then from SQLAlchemy .x .async IO import, create our async engine, and also async session maker to manage our sessions, and async session actually. Okay, so we then create our database class. This is wrong. Our class database. We then have our init. Self takes in the URL, which is a string. Then it takes in also the engine keyword argument, which is going to come as a dict. So it returns none. So we then say self dot engine is what? Our create async engine for our database and engine quirks. So we then say our self.section factory for our sessions. Session factory is equal to async session maker we then say bind on, again you can only know this when you go to the documentation, self.engine, then we have expire on commit false, expire on commit false. We then have our class is equal to our async session. We then have our auto flush to false, auto flush to false. Then we have our auto commit to false. Okay, so we then need to have our things like def, define our session. Our synchronous session should be self, and this returns our asynchronous session, async session. Then it returns self.session factory. We then have a property of this class to be an engine, a DB engine. Self, this should return what? Return self.engine. We also need to have a method to create all our tables. Async def create all tables, which is going to be our self, return none. So async with self.engine.begin as connection. We then say await connection.run sync to do what? Base.metadata from our base dot creates all tables. Then we also have our dispose to dispose our connection. Async def dispose for when we shut off our API. Dispose all connection. Self return none. And self.engine. We have to await this. Await self.engine is an asynchronous operation. Self.engine.dispose. Yeah. So we then have to wire up our prediction table, or let's call it our prediction log. Yes, let's call it our prediction log. So we then import from SRC. Before we import SRC, let's import from SQLAlchemy. Import boolean data type. Import boolean. Import column. Import date time. Import floats. Import integer. Import JSON. Import string. And we then know string. Why are you autocorrecting? I don't need to autocorrect me. So we then do from SQLAlchemy dot SQL import func once again. Then we then import our base from src dot infrastructure dot db dot base, imports our base class. We then define our prediction log. So we make it inherit our base class, which we then make it have things like id, created at, updated at, deleted at. Okay. So instead of using that table name generation, we can just have our table name, define our table name ourselves, and call it our prediction logs. Okay. So we don't need id anymore. We then say image url is what, column string, which is string data type, nullable. We don't want it to be nullable. Nullable is false. For every record, we actually need a URL. We need detections to also be a column, which would be a JSON data type. Nullable is nullable. It should not also be nullable. We also need a model version is equal to column. This will be a string. This should also be non-nullable, but should have a default. Default is what? Let's just say v1.0. We then say confidence scores. Scores is what's also a column of JSON, also non-nullable, false, and we then define our review columns. We then say actual label is equal to column string. This should be nullable. Nullable is equal to true. We then have is correct for, let's say, when the model was correct, is equal to column, but now will be a boolean data type, boolean, also nullable. We then have our reviewed at to be column also, but now will be date, time, and also nullable, because we only fill this record when we have carried out a review for that particular record. So we have this now, we have our session, we have our prediction log, we have our base. So we then have to wire them, or actually add them to our DI container. Okay. So we then have to define our database up here. So we say DB engine is what? Again, we only want to create one of these, providers.singleton. We then say our URL. Let's fetch one of the things that we have here. We are providing our URL here. Our URL is equal to, let's get our URL from settings here. Okay. Cool. So we then need to have something like our pool size. But now, since we are using asynchronous operations, we will need to do something to actually convert our URL to an async URL. We need to replace our PostgreSQL that is here, or SQLite in this instance. Let me just give an AI model to help us solve this. Complete replacing this SQLite to async URL from sync to async. So let's let our AI model do it for us, so we won't have to worry about that. So let's give it our DB engine. Okay, give us what we need. Okay, so it has given that to us. Since we are not using Postgres, let's proceed with our SQLites. Okay, so we then proceed to say, give us a pool size of, like, let's say 10. Give us a max overflow of 5. Give us a pool timeout of 30. Give us a pool recycle of 300. And pool pre-ping for fast queries. Pool pre-ping. Again, you would only know all this when you've gone through the documentation or used it severally. Pool pre-ping to true. So we now have our DB engine, we have our model bundle, we have our runner, we have our storage. Now we'll need to have two more things, which is our prediction repository and our prediction service. So we need to have our prediction repository. So let's come here, prediction repository. .py and our prediction service .py. Okay, so in our next video we are going to be proceeding to have our prediction repository and our prediction service, so that we can start testing our inferences and see that we persist them to the database. So see you in our next video. Don't forget to like, subscribe, and share.